Good morning. Welcome back. I told you I'll spend a couple of lessons trying to discuss questions that involve application of maximum and minimum to physical situations, or what some of us teachers call it as verbal problems. You have to make up a model and everything. So we are still in topic 6. Still in differentiation. It will be there for another 7-8 lessons, I think. And now, so we're looking at application of maximum, minimum. I don't want to write everything, to practical problems. In order to save time, I have written down the question on the left. Of course, my handwriting, by the way, is the best in the world. So you won't be able to understand anything. What I'll do is I'll read, underline the important points, build a mathematical model, solve it, and let you know. Oh, by the way, my name is Sosale Mohana. I'm a maths teacher. For over 50 years, I've taught A-level for maths and further maths. And I'm trying to help students revise and prepare for the exams based on what they have learned in school. I'm just reinforcing what has been taught in school. So let's do some of these questions. Okay, let me read the first question. An open tank without a lid is constructed using a metal sheet of area 4 meters square. So there is an area of 4 meters square. So you take a sheet and then cut up and then make the 4 sides. It's an open tank. So 4 sides and the base, but the top is open. So the tank, always draw a rough diagram to understand the situation. See, I'm going to give you the notes. So that is the top of the tank. That is a tank. Of course, my drawing ability, of course, is very poor, as you can see. Very clever, yeah? Let me draw a better diagram. It's not that bad. It's a square base. There, that's a better tank, isn't it? This side is open. That means you've got the sides. You don't know anything about the sides. So the first job will be understand what the question says. You've been told it has a square base. We don't know the dimension of this. That means I can vary the size of the base. So that's a variable there, x. That's a variable there, x. And I don't even know the height. So let's call the height as h. So first job is read and understand the question. Where necessary, draw a diagram. Identify the variables. Call them as x, y, z, whatever variable you want. Agreed? So, and you're being told, find its dimensions. That means I need to know what is height, what is x, when. If its volume is maximum. Next step will be identify the quantity that has to be a maximum or a minimum. In this case, the volume should be maximum. So volume V equals, once you identify, write it in terms of the variables you have labeled or nominated or designated or identified. So the volume is x squared h, and I want to find the maximum volume. So now my mathematical model is complete. But to find maximum minimum, I have to differentiate. I cannot differentiate because I've got two variables there. So unless I have only one variable, there is no way I can differentiate. So either everything should be in terms of h or everything should be in terms of x. Okay? To do that, what is the other information given? The metal sheet of area 4, that means the total surface area of this particular tank is 4. What is the surface area? 1 base plus 4 sides, correct? That is XH, XH, XH and XH. That is given to be 4. Yeah. So therefore, I can make H the subject or X the subject. I cannot make X the subject because it's a quadratic. So make H the subject. So in other words, your effort must be to find everything in terms of one variable. Okay. So volume therefore will become x squared times 4 minus x squared over 4x. Can we simplify that? That's a quarter x times 4 minus x squared. Or I can say, now I don't need the diagram. So I'll get rid of the diagram. So volume equals quarter times 4x minus x cube. Very good. How do you find maximum, minimum? Differentiate. So dv by dx equal to quarter times 4 minus 3x squared. Equate it to 0. 3x squared equal to 4. X squared equal to 4 over 3. So x equal to 2 over root 3 times root 3 over root 3. So 2 root 3 over 3. Yeah. I found what is x. Find dy by dx, equate dy by dx to 0. Find the value of x. But it says maximum, so I need to show it is maximum. Remember I told you, even if the question says maximum, it is your responsibility to show it is maximum. So what is d squared v by dx squared? Is quarter times 0 minus 6x. At x equal to 2 root 3 over 3, it is negative, therefore maximum. Now, interpret your answers based on the question. The question is not asking for maximum volume, but the question is asking for what are the dimensions. So I got x equal to 2 root 3 over 3 and we had h is equal to, what did I have h as? I rubbed it off. Hey, test of memory, yeah? H would be 4 minus x squared over 4x. Clever. So that is 4 minus 2 root, what is x squared? 4 over 3 divided by 4 times 2 root 3 over 3. 3 for the 12, 12 minus 4 is 8 over 3. 8 over 3 divided by 8 root 3 over 3. Or 8 over 3 times 3 over 8 root 3. That's 1 over root 3 or root 3 by 3. So therefore, base side is 2 root 3 over 3 meters and then the height is root 3 over 3 meters. A typical question, remember, on the diagram identify the variables, draw a diagram if needed, write down the quantity that should be maximum or minimum, use any information given in the question to convert everything to one variable, do dy by dx, equate it to 0, find the value of x, test for maximum, minimum, and interpret your answer based on the question. There is a second question. I want to do about 6 questions in this lesson 3 and in the next lesson 3. So what's the next question? I've taken 10 minutes, so I might be able to do only 2. We'll see. A rectangle is constructed inside a circle of radius r. So there is a circle of radius r and you are constructing a rectangle. I've already read the question, that's how I put it. Of course, I could have constructed the rectangle like this. But it says the vertices of the rectangle lie on the circumference of the circle. So my diagram was correct. Agreed? Now the radius is r. You're asked to show that the maximum area of the rectangle. Now look, what are the variables in this question? The length of it varies, let's call that as L. The width of it varies, let's call that as B. Yeah? The center is here. Now can somebody tell me why I put the center along the diagonal? Yes. GCSE geometry. Angle in a semicircle is a right angle. So if this is a right angle, the diagonal has to be a semicircle. Yeah. What does it want? Show that the maximum. So I have identified the variables L and B. Remember, the radius of the circle is given. That is a constant, not a variable. Very good. So the quantity that should be maximum is the area. L and B are the variables, and I must find maximum A. As usual, I cannot differentiate. Now, unless I have only one variable, either everything is L or everything is B, I purposely took L and B, not X and Y, because all of us use X and Y all the time. Okay? So therefore, I need to convert everything to one variable. Look, Pythagoras says L squared plus B squared is 2r the squared. So L squared equal to 4r squared minus B squared. So L equal to square root of 4r squared minus B squared. For heaven's sake, don't write 2r minus B. Okay? Please don't write 2r minus B. That is rubbish. Okay? Right. So area equal to B square root of 4r squared minus B squared. Now I have everything in terms of one variable B. I'll show you two different methods here. Let's do it directly, then I will show you the other method. I need to differentiate. So can I write this as B times 4r squared minus B squared power half? Please remember 4r squared r are all constants. So please don't differentiate and say 8r. So dA by dB equal to, that is U, that is V. U is B, du by dB is 1. V is 4r squared minus B squared power half. Oh, I should have put that line. So dr dV by dB is half onion rule times 4r squared minus B squared power minus half. So there are two functions. One function is the power half, which is outside. So start from outside, go in. First differentiate the power half, then differentiate inside. 4r squared gives you 0 minus 2b. Simplify that a bit. So it is minus b over root 4r squared minus b squared. So find dA by dB. So dA by dB equal to U is B dB by dx minus B over root 4r squared minus B squared plus V is root of 4r squared minus B squared. Du by dB is 1. Alright? I'll rub all these things because I don't need this anymore. I must show maximum area. We will see that in a minute. So I have all this. So can we simplify this? Let's put, look, don't try to take LCM. This way you must use common sense. Don't take LCM, equate it to 0. So what do I get? Minus B squared over root 4r squared minus B squared plus root 4r squared minus b squared equal to 0. What you do? Take LCM, simplify, get rid of mess. No, take this to the other side. So 4r squared minus b squared under root equal to b squared over under root 4r squared minus b squared. Cross multiply, 4r squared minus b squared equal to b squared. 4r squared equal to 2b squared. B squared equal to 2r squared. B equal to r root 2. Yeah, B is r root 2. I need to find L. Remember, I have L squared plus B squared equal to 4r squared. So, what is L? I can rub this off. You might be wondering, sir, why are you doing this? Yeah, because I need to find the dimensions, otherwise I can't find the area. Of course, I could use the formula, but this will be easier. So, L squared is equal to 4r squared minus b squared. That is 4r squared minus 2r squared, which is 2r squared. So, L is equal to r root 2. So, do you realize? Therefore, area is 2 root 2r times root 2r, which is 2r squared. I've done that. But if I leave it at that, I lose at least 2 marks. Why? Can somebody tell me why? I know why. Yes. True. Even though the question says maximum, you have to prove it is maximum. Otherwise, you lose 2 marks. This is where common sense might help you. What is your dA by dr? Your dA by dr is that, dA by dB. Now, to differentiate this again is going to take ages, isn't it? Can you imagine differentiating that again? Going to take ages. Then this is where gradients you can use. B is r root 2. That is 1.414r. So I need to take a value less than that and a value more than that. So I'll put B, dA by dB and sketch. If they don't want to, such questions they'll mention, you need not test for maximum and minimum, in which case you're lucky. But if I am, as I told you, if some examiner might say, no, sorry, you have to show me. This is, B value is r root 2. Less than that is r, more than that is 2r. I should say 1.5r, but I'll take 2r, it's easier. No, I can't take 2r. So 1.5r. Remember, if I take 2r, that becomes an asymptote. If B is r, what is the value of this? R squared minus r squared over 3r squared, isn't it? So, minus r squared over 3r squared plus root of 3r squared plus root of 3r squared. Correct? Now, forget the r squared. 1 over root 3 is smaller than root 3, so it's going to be positive. There it is 0. If you take 1.5, 1.5r is similarly 3 over 2, 9 over 4, negative 9 over 4 over something over 3 over 2r, and that one is 3 over 2r. 4r squared minus 9 over 4r squared. 4r squared minus 16 by 7, root 7. So this is going to be negative. Right? So therefore, like that. So it's a maximum. But in most of the questions, they will definitely say, do not test for maximum, minimum, because it's going to be quite cumbersome. So what I'll do is, I will start this lesson again after writing the next question. Let's look at this question now. A right circular cone has a slant height h. It has to be right circular cone because any cone, because of symmetry, we need the right circular cone. So that slant height is L. Okay. find in terms of pi and L the area of the circular base. So I want the area of this base when the volume is maximum. So the variables there are the height h and the radius r. And you are being told that I want in terms of pi and L the area of the base. If I want the area of the base, that area will be pi r squared. So that means I need the r, I don't really need the h. What is the volume formula? Is 1/3 pi r square h. And I need to find maximum V. So let me repeat. Read the question. Draw a diagram if necessary. Identify the variables. Write down an expression for the quantity that should be maximum or minimum in terms of the variables. But then I cannot differentiate this because I have an H and an R. Then use information given in the question to reduce everything to one variable before differentiating. Yeah? Of course, if you do maths at university, you can do partial derivatives. I'm not going into that. Okay? So therefore, either I have to get rid of R or I have to get rid of H. What information do I have? I know this L is a constant. Don't forget, you're being given. So I can say R squared plus H squared is equal to L squared. What I'll do is, you might be wondering, sir, if I make H the subject, I'm going to get a square root, isn't it? Make R the subject, find H, and then we can find R. That's easier. So R squared equal to L squared minus H squared. You could as well do H squared equal to take square root, but see, that way I am avoiding horrible differentiation. 1/3 pi h times L squared minus H squared. Please understand, L is a constant. So V is equal to 1/3 pi times L squared h minus h cube. Otherwise, look, I would have 1/3 r squared times square root of L squared minus r squared, and you have to use product rule. You're making life more difficult. By writing h squared in terms of r squared, your differentiation has become easier. So let's do dv by dh is 1/3 pi times L squared is a constant. H gives you 1, 3h squared. Equate it to 0. H squared equal to L squared over 3. H equal to L over root 3 or L root 3 over 3. I don't even need that. Doesn't matter. What are you asked to find? You're not asked to check for maximum, minimum. So I'm assuming that this is going to give maximum. Even otherwise, common sense. When you differentiate this, I get L squared minus, 0 minus 6h. Negative 6h is going to be maximum, so I don't have to bother. So therefore, R squared equal to L squared minus L squared over 3, which is 2L squared over 3. So area of base equals pi times 2L squared over 3 or 2 pi L squared over 3 when volume is maximum. So in most of the questions at A level, you may not have specific values. It will always be a third variable. In the next lesson, I'll stop at this stage. In the next lesson, what I will do will be do 1 or 2 questions on this and 1 on trigonometry, maximum minimum of a trigonometric function. Even though that won't be a practical application, it will just be an application. Okay. Of course, I could say a curve, or a Geiger counter, or how you pronounce it, I don't know. The wave is given by 2 cos 2x minus 3 sin x plus 5. Find the maximum wavelength or find the amplitude, something like that. So I can't make up those questions because that is a specialty. So I'll just pick up a question and do it. The title will be there. Probably for the very last question, the title will be a bit misleading. I'll see you in the next lesson. Bye bye. Hello. I want to take this opportunity to propose a vote of thanks. I would like to thank Vivid Innovations Private Limited and Commerce Forum for so generously giving up their studio and the facilities and the services of their technicians to record all these videos for free. I think that needs to be acknowledged and appreciated. Thank you very much. And my special thanks to Mr. Nitin Mahadevappa, Mr. Nishant Guruswamy, and Mr. Sadan Kumar DN for all their help and assistance in getting these videos ready, uploaded, and launched. Thank you very much.